Welcome to the series of the solutions to the free LawPrep. In this video, we will be dealing with the third set of analytical reasoning problems in the free LawPrep. This set of problems is rather sweet, literally, because it deals with a couple of people who've gone to a cafe and are going to order some desserts according to some rules. In this video, we will learn the technique of diagramming by making a table and then putting some checkboxes. Let's go ahead.
Let us begin with a little exercise for you. Look, a good way of solving the LSAT India analytical reasoning section is to first focus on the conditions on the data that is given to you. And in most cases, it will help you to draw a diagram or a table. Okay. Now, in this diagram or table that you draw, first enter the data that is given to you expressly, which means that it is actually given to you as a point. Okay. Enter this data into it. Once you're done with that, you'd see that on the basis of what you've entered, you can probably enter a few more things. Okay, do that as well. And then once you're done with that, we have a master diagram, right? We create a diagram that we can use now when we approach the questions individually. So pause the video and try drawing this diagram by yourself. We will do it together once you're done. Right, so let us go for this together to draw the diagram first. Now what you see here is that there are 6 people, okay? And again, you can just replace their names by the first alphabet because you can see that they're all distinct. So there are 6 people and there are 3 sweets, okay? Which means that if each person is ordering at least one, which means that they order either 1, 2 or 3. That means there are 6 people and each of these persons either orders 1 or 2 or 3. Okay, so what kind of a table do you think we'd have? Let's go ahead and have a look. You see, this table gives you the 6 people that you have who are ordering the sweets, and here you have the 3 sweets. So let us say if this person here has ordered 3 sweets, then I can just go about giving 3 tick marks here. If I come to know that maybe this person here has ordered 2 sweets and not ordered 1, maybe she's not ordered this, then I go ahead and give 2 tick marks here. Remember that you cannot have a situation where there are 3 crosses because every person orders at least 1, okay, right? And no one orders more than 1 of each type of dessert, which means that you cannot have 2 tick boxes within 1. So each one orders only 1 of one type and everyone orders at least 1. So as you can see here in this table, I've simplified it. I've taken off the full names and just replaced them by the first alphabet. As you can see, all the alphabets are distinct. Sometimes you might find that, this column might have an alphabet that is the same as this, in which case maybe you can use the uppercase and the smaller case to make that distinction. Okay, let's proceed and now enter the directions into this table one by one. The first direction, exactly 2 people order pedas. Exactly 2 people order P. What that means is that in front of P here, I've written down for you that 2 people are ordering P, and that equally tells you that 4 people are not, because it says exactly 2 are. So if 2 are, it means that 4 are not. But I do not know as to where I can put the tick and the cross in here. That's why I have drawn it by the side. Okay, let's look at the second rule. The second rule says that if Kapil orders P, so I call it KP, he also orders Sandesh. So if Kapil orders P, Kapil orders S, and I've written this down here. Okay. Again, this is a rule that you'd realize cannot be written into the table, so I've written it by the side. Moving ahead. It says that J, L, and M, and nobody else order R. Okay, so I put a tick, and tick for J, L, and M, and then it says nobody else, which means I can cross out the remaining spots. There you go, I've crossed out the remaining spots. Then it says that neither H nor O orders P, so I can put a cross. Neither H nor O orders P. I put a cross there. Okay, good. Let's look at the last direction. It says L does not order S, which means I can put a cross. There you go, L does not order S. And now what we've done is we've entered everything that we had in here into this table. So is this table complete? Have we done what we had to? Recollect that I told you in the beginning of this session that after what has been given to you expressly, see if you can derive anything more. Can you fill in any more blanks? Okay, let me show you what they are. Look at this here. Do you think that there's a blank that you can fill? We'd seen that each one orders at least one dessert, which means that if H has not ordered these two, then definitely he has ordered S. Likewise, if you look here, we know for sure that again S has been ordered. Right, now that we've entered the data that was first given to us as well as what we derived, we now have with us the master diagram. It's a very important step for you to give yourself the master diagram that you can use across all of the questions now. Let us go ahead and look at the questions one by one. Before we proceed, let's say if you found this diagram a little difficult, I'd like you to pause the video and spend some time trying to draw it again by yourself. Remember that simply watching the video solutions is not going to help you unless you're an active participant in this session. Alright, the first question in this set. What is the maximum total number of desserts that the 6 people could order? Now you might be tempted to think, hey, there are 6 people, there are 3 sweets, 6 into 3, 18 spots. So the answer is 18. But when you look here, you don't find 18. This is because what you have ignored perhaps is that some of these have been crossed out. Okay. So you're supposed to see how many seats remain after you have crossed them out. It's kind of like when you travel, let's say when you're booking a bus seat or maybe a seat in a flight. Okay, so you have this diagram, this layout before you where you have all of these seats. Okay, and you know that maybe 2 of them have been booked, right? These 2 have been booked. Now, what is the maximum number of seats that you can book? You may just want to book 1, but what is the maximum that you can? It is these remaining ones. In this case, the maximum is 4, right? You may book only 1 seat. You may book only 2 seats, but the maximum possible is 4. So what we will do now is that we will identify the number of crosses, okay? And then subtract that from 18 to get the answer. Let's go ahead and do that. So we are now counting the number of crossed out boxes. Let us start with the first sweet here. What is the number of crossed out boxes? You see 2. This is where you might be wrong. The answer is 4. If you remember that there are 4 crossed out boxes in here. You don't know as to where the other 2 boxes, the crossed boxes are. It could be any of these 4. But you know for a fact that there are 4 crossed out boxes here. Let's look at the next one. Here we see 3 crossed out boxes, okay, and in the last one you can see only 1 crossed out box. Now what is the total number of desserts that 6 people could order? You see the total number minus the number of crossed out boxes. So here the total of this is 8 crossed out boxes. So the non crossed out boxes is the maximum possible, and therefore the answer to this is 10. You may have seen as to how helpful it is to have this master diagram. Try solving the question yourself and then we'll go for it together. So what you see in this question statement are basically a few more rules in addition to the rules given in the master diagram. So the master diagram is a set of rules that applies to all of the questions, and this is a rule. So if exactly to blah 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 is a rule that applies only to this particular question. Okay. So what we do is we add these rules to the master diagram. Okay. So it says 2 people, only 2 people have P and R and nothing else, which means that they do not have S. Now what does that tell you? Anyone who is having S cannot be one of these 2 people, because it says that these 2 people, whoever these 2 people are out of these 6, do not have anything apart from P and R, which means the people who are having S cannot be these 2 people, because you see here H is having S and you see that even O has S. Therefore anyone who eats these cannot be one of these 2 people. Let's look at something else. These 2 people must have both P and R. If you look at K, K does not have R, which means that K cannot be one of these 2 people again. Now this leaves us with 3 choices for the people who can be these 2 people. I hope you follow what I'm saying. If not, pause the video, listen to it again, try it by yourself. What we have as of now is that we have only 3 possibilities for these 2 people. Now I want you to look at the nature of the question. It says which one of the following must be false, which means that which is the one that is false in all cases. Okay. Now, you know what? You might get scared initially when you see that, oh my god, there are three spots and I don't know which two people to choose. We're only trying to see in this case, when you're looking to solve a must be false question, you're looking at the options which could be true. So when you find three options that could be true, you know that they are not the answer, right? So you're not looking to find out which two people they are. You are trying to see as to what could be true so that you can find out as to what must be false. Okay, so don't feel disheartened in such questions. Don't needlessly do some guesswork. When you just enter the data that is given to you, you will be able to solve the question. Now let us see what we have here. Now we know that there are three possibilities for these two people. So either it could be J and L. So in case it is J and L, then basically we have a tick mark here and we put a cross here, right? This could be the first case. Or it could be L and M, who are the two people who have this, in which case we'll put a cross here. Okay. Or we know that it could be J and M, in which case what we'll do is we'll put a tick here and we'll put a cross here. Now what I want you to remember is, at this point, once you know that there are these three possibilities, let's go and look at the options here. Okay, it says we know that these were the possibilities. Okay, so let's look at the first option. Madhu orders only rasmalai. Is it possible for Madhu to order only rasmalai? Yes, of course it is possible. If we decide that J and L, if we decide that J and L are the people who get it, let's say I put this and this, in that case it is possible that you can have only rasmalai being ordered by Madhu because you can put a cross in both these places, so it could be true. Okay, likewise let's go ahead and see if we can see the same with the next option. Hari orders exactly one dessert. We know that Hari definitely orders only one dessert. We've seen that Hari can only order sundae, so this is definitely true. Let's look at C. Jasbir orders both rasmalai and sundaes. Jasbir orders both R and S, which means that if Jasbir is ordering both R and S, okay, then he is definitely not one of these two people. Okay, then those two people are L and M, and we just saw this is also possible. Now you look at the last option. It says K orders both P and S. Now what is the problem if K orders both P and S? You see, K we saw is not one of these two people, which means let's say we put K and S here. Okay, let's say we've put these. Now what is the problem? The problem is that in addition to K, we have two more people out of these three who will have to order P, right? And let us say any two of these order P, then the problem is that you will have a total of three tick marks for P, but we know that only two people order P and four do not. So it is not possible for K to order P, and therefore we know that K cannot order P, and so we know that in all conditions this has to be false, and therefore option D must be false. A reasonably challenging question. If you didn't completely understand it, spend time until you do. Do not bypass a question that you do not understand. That is a complete waste of your time. Alright, good question once again. Reasonably challenging. Try solving it by yourself. Remember that if you are going to simply just look at answers and dodge the questions that you find difficult, you're missing out on the journey that gives you the improvement that you need for the LSAT India. Okay? Pause the video, try solving it by yourself. I'm going ahead with the solutions now. Let's go through this together. If you looked at the first question that we solved, we saw that the maximum number of desserts possible was 10, which means that 10 is the maximum. Okay, and now you're being told that 8 desserts are ordered in this case, which means that the maximum, like I showed you the bus seats, like I showed you that let's say there are a total of 6 seats in this bus. We saw that 2 of these had been crossed out, and now there are 4 available. Okay, so the maximum is 10. but only 8 have been ordered. It's like saying that, hey, there was 4 available, but you chose only 2, which means that there has to be an additional cross in 2 more, right? So there are some positions, right, which are vacant, on which you're putting a cross. So you have to see which are those positions in which there could be a cross or a tick. Okay, let's go for it together. If you want, you can still pause the video and think about it by yourself before you listen to what I'm saying. Okay, now the other interesting thing here is that it talks about the desserts that are ordered, not so much about who ate them. And that's another very important line of thought. Okay, so let's look at the desserts one by one without focusing so much on the people. You'd see when we solve this that the people as such don't so much matter. Okay, what is the number of people that could have eaten P? Is that fixed or is that variable? Is that fixed or is that variable? You see, this is fixed. We know that exactly 2 people have eaten P. So when you're talking about the total number of desserts that have been added, you know that for sure 2P is fixed, right? So the desserts are basically P, R and S. We have to total this, right? So 2P is fixed. Next, look at R. What is the number of people who have eaten or ordered R? Is this variable or is this fixed? You can see here that there are exactly 3 people who have eaten and 3 people who have not, which means this is also fixed. So when I write this here, we know that this is 3R. This is also fixed. Now, what is the total of P, R and S? We know it is 8. Okay. So out of this 8, we know that 2 are P, 3 are S, which makes a total of 5. So what is the number of S that should be there so that the total is 8? So 5 plus what is 8? It is 3, which means you have 3 sundaes. And now you look at the options and you find that the answer is right there in option D. Okay, I hope you realize how easy it becomes once you understand how to use the diagram. Let us proceed further. Pause the video, try solving it by yourself, and then we'll go for it together. Okay, in questions such as these, one of the most important points is being able to understand the question correctly. It says, which one of the following must be true? Which means that out of these 4 options here, you know that one of these options must be true. Okay, and that's your right answer. That's the correct answer. Okay. What can you say about the other 3 options which are wrong? So you know in here that the other 3 options are wrong. So what can you say about these statements? I want you to think about it. Okay. So you know that if one option must be true, it means that there is no possibility of that being false, right? It is not possible for it to be false. It only has to be true. Whereas the wrong answers could be true or could be false, right? So basically, if you have to eliminate the options, okay, now you see, why am I talking about could be? Because you know there are vacant spots in here. You don't know whether in these spots there's a tick or a cross. You know, it could be any of these. So now when you're looking at the right answer, which is something that must be true, it means it is true in all cases. Whereas the other 3 could be false. You know, if we find that they could be false, it means, hey, you cannot say that they must be true. So how do you arrive at the answer in such questions? I'm telling you the method. The method is the method of elimination. So you pick each option. So for example, you pick the first option, option A, and you ask yourself the question, hey, could this be false? And to see if it could be false, you try to do the opposite of what is given in there. I'll just demonstrate that to you in a bit. But let's say you ask yourself for option A, hey, could this be false? Then you ask for B, hey, could this be false? For C, could this be false? D, could this be false? You ask this question for all 4. Okay. For 3 of them, you will say, yes, they could be false. You'd find that. And then there'll be one option for which you cannot answer this question in the affirmative. You'll have to say, could this be false? No, this could not be false. If it could not be false, it means it must be true, and that is your answer. So the method, as I just showed you, is that you look and ask yourself the question, could this be false? And the one for which you get no is the answer. Okay. So let's go for this option by option. Okay. Let's pick the first option, A. It says at least one person who orders P, one person who orders pedas also orders sandesh. It means at least one person who orders pedas also orders sandesh. So it's saying that one or more, that's what the meaning of at least one is. One or more persons orders P and S. This is what the statement is saying. Option A is saying. Now you ask yourself the question, hey, could this be false? Which means, is it possible for us not to have one or more people ordering this? Which basically means, can we have zero people or basically no person ordering P and S? I hope you understand. When you're trying to see if this can be false, the statement is saying one or more. Okay? And when you want to find out if this could be false, you're looking whether it is possible for no person to order both P and S. So let me see if it is possible for me to make any one of these people, to make an arrangement where nobody orders P and S. Okay. So let's say maybe I have all of these people. Let's say two people are buying peda. Let's say, I need to put P here, and so it's here. So I take a tick mark here, right? Let me make J by P. So here you have P, and let's say you put another P maybe here. Okay. And now of course you can have only two P's at the most in this line, because you see four have to be blank. Okay. And now I cross out the sandesh here, and I cross out the sandesh is already crossed out here in here and here. Okay. And then let me do the same thing here. Of course there's a cross already, so you can see that there is no person in here, no person in this entire table has who has ordered pedas and also ordered sandesh. You see, the person who's ordered pedas are J and L, and they've not ordered sandesh, which means that I have been able to falsify this. So this could be false, right? Therefore this is not the answer, because the answer to this question was yes. Let us proceed to the next option and ask ourselves the same question. Okay, so let's look at option B. Option B reads, at least one person who orders R also orders pedas, which means that one or more person who orders rasmalai also orders pedas, right? That means you're saying again that one or more persons orders R and P. Oh, now you ask us the same question, could this be false? So what's your question basically? Is it possible for us to have zero people who order R and P? This is what we are looking at. Let's see if this is possible. Okay, so let me just erase what I had done here. Let's see if it is possible for us to have zero people who order both R and P. Okay, now who are the people who are ordering R? If you can see, R has been ordered by these three people. Okay, which means that definitely we have to look only at these three, because you see the other three have not ordered R, right? So these three people are not the ones we're seeing. Now we are trying to see, is it possible for all of these three people not to order P? So let me see if it's possible for me to put three crosses here. Is it possible for me to put three crosses here? Let's say I take this and I put a cross, I put a cross, I put a cross. Is it possible for me to do this? Is it possible for me to show that you can have 0, R and P? You realize that if you do this, you're supposed to have only 4 crosses here and 2 ticks, but now you have got 1, 2, 3, 4 and 5 here. So this is not possible. So now in this case, you know that this cannot happen, right? Which means that it is not possible for this to be false. Therefore, B becomes the answer. Okay. I want you to go ahead and try this method out with the remaining 2 options by yourself. When you ask yourself, hey, could this be false? The answer to that will be yes. Practice this. Once you learn the method, you know how to solve these questions very easily. Let's go ahead. Alright, after a must be true question, we have a must be false question. Try solving it by yourself. Okay, let's go for this together now. If you see that one of the following must be false, which means that out of the 4 options, one of them must be false, and this is the correct answer. So what can you say about the other 3 options that are wrong? What you can say about them is that the other 3 could be true. Okay, so like with the previous question, what we're going to do now is use the process of elimination. Okay, so we'll pick each option, like we take the first option and we ask ourselves, hey, could this be true? Second option, could this be true? Third option, could this be true? Fourth option, could this be true? Okay, now if something could be true, which means if the answer is yes, if something could be true, it means it is not necessary that it must be false. That means the answer is wrong. And that's what 3 options will give you. So out of these 4, when you ask the question, could this be true? 3 will say yes. And then there will be 1 option to which the answer will be no. This cannot be true ever. If it cannot be true, it means it must be false, and therefore that will be your correct answer. So let us go through this method together now. Let us ask the question, could this be true, for each of the options, and arrive at the answer. Let's begin with option A, and we ask ourselves the question for option A. The question being, hey, could this be true? Could option A be true? Which means we're asking ourselves, is it possible that only one person, exactly one person, orders more than one dessert? Could this be true? We're going to ask ourselves this question. So is it possible that only 1 out of these 6 people orders more than one dessert? This is the question that we are asking ourselves to find the answer. Okay. Now I want you to observe that there are 2 people here, H and O, who are ordering exactly one dessert, which means H and O surely cannot be these people, right? Because H and O are ordering only one. So definitely H and O are not that one person. Okay, which means that one person has to be one of these 4. Okay, let's try it one by one. Could J be that person? Could K be that person? Could L be that person? Could M be that person? Okay, let us say we start off with J. Okay, so we're asking ourselves the question as to whether J could be that one person who orders more than one dessert and the others order only one dessert. Okay, so let me say we give J, maybe we give him peda. Okay, now we've given him a peda, which means that he has 2 now. You can see that he has 2. Okay, which means the others should not get more than 1, which means that, let me put a cross here for L, right, because we do not want L to have more than 1. Similarly, let me put a cross, 2 crosses for M here, because they should not have more than 1. Now if you look at K, okay, if I were to put a tick here, if I were to do this, then we know that because of this rule, automatically this will also become a tick mark here, which means I cannot put a tick there for K. I'll have to put a cross here. Now when I do this, in this case, what you can see is that there's a problem, that you have, instead of 4 crosses, you have 5 crosses here, which is not okay, which is not fine. Therefore I can understand that it is not possible for J to be that one person. Okay, so let me see now that since J cannot be that person, let me see if maybe it can be K. Let's move on to K. So we definitely know that it's not. So as of now we know it's not H, it is not J, it is not O. Let's try it with K. Can K be the one person who orders more than one dessert? So let me give K 2 desserts now. Okay, so when we give him 2 desserts, we put 2 ticks on him. We give him this and this. Now if he has 2 ticks, it means everywhere else there need to be crosses. So cross, 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 cross. Now same problem, 1 tick and 5 crosses when it was supposed to be 2 and 4. Which means that even K cannot be that person. Which means that as of now we've understood that even K cannot be the person who is ordering more than one dessert. So let's change this also to a cross here. K cannot be a person. Let's now try it with L. Can L maybe be the person who orders more than one dessert? Again, when you do the same thing, you'll put a tick here for L, right? And then you'll have to put a cross everywhere else. You have to put a cross here, you have to put a cross here, and again you'll find the same problem here. Okay, that 2 and 4 instead of 1 and 5. Let's finally see if it's possible for M to be that one person. Okay, so what we'll do is that we'll have to put a tick mark for M. Let's say we put a tick mark here for M. Okay, and then we put a, maybe this could be a tick. Let's not put a cross there, but here we have M, and then it has to be a cross, cross, cross. Gives you the same problem once again here. Therefore, you could see that this could not be true. The first option, A, could not be true in any situation. We tried all cases. It is not possible for A to be true. What does that mean? If something could not be true, then it must be false. And therefore, A is your answer. I don't need to go to the other options because I found my answer right away. But what I'd advise you to do is to look at the other three options and try asking yourself the question, could B be true? Could C be true? Could D be true? In each of these, you will get the answer yes. Okay, so make sure you practice this by yourself. Don't simply watch the video and not practice it. You will not benefit the way you should. Okay, so this ends the session on the second set of analytical reasoning questions. I hope you found this useful. See you in the next lesson.